Hitachi 65R80. This is a Roku TV 65-inch LED. It's come to repair for no power. So let's plug it. No standby light. Pushing the power button. No picture. Nothing at all. So let's put this one on the ground, and we switch to the voltage first, because we have no power. We're gonna go and check the power supply first. So for the cord that's going to the main board, this one here, if you follow it, it's going to the main board. We have 24 volt. We have 0 volt here. All right. So next step after that, we have to check. Let me see if I can do it. Okay. So we check in these big capacitors here. So on this big capacitor, we have to find like 160 or 390, but we have 0 here. We don't have no voltage. So the same thing in this here in the rectifier bridge between the positive and negative, the 0 volt. So I unplug the power cord, and we're going to switch to check if there is the continuity, and we check this fuse here. The fuse is open. It's hard for me to hold the multimeter as well. It's hard for me to hold the phone and the multimeter probe, but I try. So here the fuse is open. So if the fuse is open, it means there is something causing the fuse to burn. We are not going to go and change the fuse till we check good here. So the first we are going to check. So from the power is comes here, let's go to these coils, then it's go to the rectifier bridge. So in this rectifier bridge, we have like a wave symbol here between these two, and we check here. We have no surge in the input. 110 is come to these two pins, and is come out 160 DC. So let's check on the output. We have a surge here. So we have a surge in this output. Most of the time is not the rectifier. From the rectifier bridge is sent the voltage to one of these ICs here. So we are going to check these ICs for surge. So this one has no surge. No surge. Here we have a surge. The diode, there is no surge. So this IC here, this one here, it has a surge, and that surge is causing the fuse to open. And so I'm going to take the board and we check more if this is the only thing is bad or could be something else. Plus that's one. So this is a N MOSFET. No, this is one. Is when you see screen like this is mean all shorted. I'm gonna go on the computer and see if this two here is basically is kind of, this one is more amp. This is 20N60C3 and this one here is a 47N60C3. This one is a 20 amp 600 volt. This one here is a 47 amp 60 volt 600 volt. So I want to be sure on the computer. Just I want to be sure the replacement component is the same as the old one. So this is the 20N60C3. You can see it is a 650 volt and 20 amp. We can see here the symbol how it's look like, and we have a diode zener. You can see that line is not straight. It means this is a diode zener, and it's going from the pin number 3 to the pin number 2, going up. So the replacement diode is here, is a 47N60C3, is a 650 volt, 47 amp, and the symbol is going the diode from the pin number 3 to the pin number 2. So everything looks the same. That's great. So that's what we need. So before we solder the new MOSFET, let's make some tests. So we had a short here, so the short is gone, and the test that I want to do is, because that's the source, this is the drain, and this is the gauge. Okay, because this one is shorted completely, is shorted here, and here we had 160 volt. All right, so we have 160 volt here. For you to know, the power is come to the source, to this pan here. Depend how the power supply design it. So some power supply, we have the source is connected to the positive, and some other power supplies, the source is connected to the negative of the rectifier bridge. The negative of the rectifier bridge, that's what's gonna be the ground. So in this case, the source is connected to the ground. If we follow the negative side, is going here, it's going here, it's going all the way here. We have the capacitors here to the negative side of the capacitor. Then we have our resistors here, 3 resistors. Then we have a jumper here. Then this is the source. You can see a S over there. So in that source, when the MOSFET is shorted, so in the source is the MOSFET is open close, is send the signal to the transformer. Transformer is shorting the ground to the positive side. If we follow here the positive side, we have varistor here, and it's go to the transformer. You can see it. This is the transformer here. So when we have a short here, it means 160 is going to the gauge, because we have a short here. 160 is going to the gauge. The gauge is the pin that getting the signal from the the switching IC. This is the IC that's telling the MOSFET to open it and close, sending that signal to the gate. That signal, it should be like between 5 to 10 volt, not 160. It's not, this IC or this little component cannot handle the 160. If the MOSFET is short, it means 160 is go to this little component and is gonna go to the IC. That's why we need to check here to be sure that if there is any short diode or this IC is bad. If we put the MOSFET and we plug the board to the power, the MOSFET is gonna burn again. So let's start testing from the gate. So this is the gate. We have a resistor here, we have resistor here, we have diode, and from that diode we have this IC here, and we have a resistors, and from that resistors is going to the IC. So here, let's check these resistors here. This is a low ohm resistors, they are good. We have a jumper here is good. We have a diodes here. Let's check these diodes to make. So if we flip, we have reading, good. No reading this way. If we flip, we have reading, that's good. Okay, these two diodes here, we're gonna need to remove them from the board because we have the resistors. That's so we're gonna respect the direction of the diode. You can't. So I'm just gonna turn the diode a little bit and I solder the pin just for me to test it. Let me show you. Try to zoom. You can see this diode here. I turn it a little bit, and this one I turn it a little bit. Let me see if I can see the multimeter with you. I think I put the multimeter here because the light. And let's test. So this way here, we have a reading. If we flip, we have no reading. Good. So this one here, we have reading. If we flip, no reading. That's good. All right. So next we're going to test the resistors. This resistor here is a 20 kilo ohm. You can see it over there is good. This resistor here is a 150, it means 15 ohm. Is good. This resistor here is a 101, is mean 100 ohm. It's good. This resistor 101 is mean 100 ohm. It's good. Yeah, look like that's good. And we have a diode here, so let's test this diode. So we have a diode here. So this diode is good. Alright, like here we have a reading. If we flip, no reading. Good. So everything is good. Let's solder the component in the place.
Yeah. And I was like, this board is expensive. All I found on eBay is one board and it was like 170. So So if we get this board to work, that's going to be good. Saving the customer some money. Some here. Some here.
Watch for the solder pieces. Sometimes they may cause the short if you lift them in the board.
Okay. Now everything looks good here. Next, we're going to remove the fuse. So yeah, it's use a jumper and I'm going to change the fuse later. So just for test. Turn off the switch, I plug it. So I turn it on. I don't hear the fuse drone. So the fuse is still good. Let's test the voltage here. And we have 160 volt. That's good.
So let's plug it to the power. Now we have the red light. That's good. Just push power button. And they can see the backlight. Yeah, we have some lines on the screen, some picture. So this is a smart TV. It will take a minute to load the apps, and you can see it. It's fixed. So I'm gonna put it together and we test the sound. So yeah, the TV works. You can hear the volume clicking, it means the sound work. So this is all for this video. Thank you for watching. Please subscribe and see you next one.